Well, 13 more questions. In number one, the initial velocity is given. You know the time. Displacement is 125, and you got to find the final velocity. Use this equation, which is simply displacement is average velocity multiplied by time, and you find the final velocity, because the final velocity of this first case becomes the initial velocity in the second case. So now in case 2, after the brakes fail, that is the initial velocity, 20 meters per second. Time 5 seconds, the displacement is 150 meters. Looking for acceleration. Use d is bit plus 1/2 at squared and get the acceleration. Four meters per second squared. In question number 2, again it's a case 1 and case 2. The first case, its initial velocity is 0. It jumps off, so it's a freely falling object. 9.8 meters per second squared is the acceleration. Distance is 10 meters. Find the final velocity. Get it as 14 meters per second, and this is going to be the initial velocity on the person just hitting the water. So VI is 14 meters per second. Find A. VF is 0 and T is 2 seconds. Find the acceleration. Get it as -7. And remember that you could find the net force, not the force exerted by the water. You're getting the net force as mass times acceleration. The net force is 490 newtons. But remember that the weight of the person is acting down, and if the net force up has to be 490, then the water had to exert a force of 1176 newton upwards. Number 3, quite easy. At the top of the loop, the centripetal force is balancing the weight, and that's why the airplane feels weightless. (4,081 meters). Number 4, remember that at the highest point, the vertical velocity becomes 0, but the horizontal velocity is still there. So at the highest point, the velocity is v cos theta, 40 times cos 30. And the kinetic energy is given by 1/2 times mass velocity squared. It's just a matter of plugging in the numbers and calculating. So again, remember that at the highest point, because this is not an object that is thrown straight up, at the highest point it still has a velocity, and that will be the horizontal component of the velocity, which we found the kinetic energy. Number 5, when the object goes straight up, as in this case, the final velocity is 0 at the highest point. A is -9.8 because it's going up. Initial velocity is 6. Straightforward question. You can find the D, the height. 1.84 meter. 6. Good question. Is 0.6 joules for every step and for every kilogram. And therefore the total energy that the person spends is 0.6 times the number of steps. The number of steps is d by 1.5, where d is the distance and the length of each step is 1.5. That gives 24d. Number 10. I think I lost the recording for some time. Anyway, it should be clear from the calculations. So it's 19.8 meter per second, and power is energy by time, work by time. And remember that mass is area times density times velocity, because that gives you the mass in 1 second. Yes, that is mass in 1 second. Number 9 follows after all the problems at the end. Okay, 11th one. Potential energy, gravitational potential energy is equal to elastic potential energy of the spring. Straightforward question. That is x squared. So take the square root, you get 1.4 meter. That's the compression of the spring. 12 is just a change of phase, so it's mass times latent heat. And because it was given per hour, you got to divide by 3600 to change it into seconds. That's all. 20.8 joule. And now the 9th one. Pressure is forced by area. Force is pressure times area. But the force is the weight of the car. So the weight of the car is equal to pressure times area. And that's the pressure. But when you take the area, you got to multiply it with 4 because there are 4 tires. And therefore, you get 19,200 Newton is the weight of the car. Thank you.